All right, physical science students, I'm going to do numbers 10 through 15 on the Newton's second law worksheet. Yesterday we did 1 through 9, and now we move on to a series of questions involving people in elevators. So in this first question, number 10, the mass of an elevator car and one passenger is 1,000 kilograms and is supported by a single cable. Okay, good to know. You can see here's the person, here's the elevator car, there's the string. All right, so then the question for number 10 is, when the elevator is at rest, what is the tension on the cable? Okay, so I'm not going to draw the person or the car again. I'm just going to represent them as a dot. And I know that the mass of that dot, which is the car and the person, is 1,000 kilograms. All right, so what forces are acting on the elevator car? Well, gravity is always there. All right, we know that the force of gravity is always going to be pulling that down. The cable is holding it up. If the cable wasn't there, it would be falling down. So we're going to call that the force of tension. Now, this says that the elevator is at rest. So then the question is, what is the tension in the cable? Well, what does the elevator being at rest tell us? It tells us that the acceleration is 0. And that means our net force is also 0. Well, if the net force is 0, that means we have balanced forces. All right, so what are the two forces that are balanced? Tension and gravity. So our tension force must equal our gravitational force, also known as our weight. So what is the weight of this 1,000 kilogram mass? Well, we have to put it into our weight equation. Fg equals mass times gravity. We've done this several times before. And so that's going to be 1,000 kilograms times 9.8 meters per second per second. And 9.8 times 1,000 is 9,800 newtons. And so that is the weight. And therefore, that is our tension force as well, because it has to be the same because they're balanced. So the answer is B. Okay, so now what happens next? In number 11, the elevator begins to accelerate upwards. How will the tension in the cable change? Okay, so let's again represent the human and the car as a dot. And now we know that it is going to start accelerating upward. Well, if you have an acceleration in one direction, it means that the net force must also be in that direction. We still have the force of gravity. But now the tension force has to be greater than that. And because if you have an acceleration, that means you have unbalanced forces. And the force that's in the direction of that acceleration must be greater than the force that it's acting against. So if the tension force was equal to weight before, it is now greater. That means it had to increase. All right, let's move on to number 12. When the elevator reaches a constant speed, the tension would be, all right, so what are we looking at here? We've got a constant speed. Why is that important? That is one of those key phrases that we look for. Constant speed means acceleration equals 0. It's not getting faster, it's not getting slower. So the acceleration is 0 here, which means our net force is 0 as well, which means we are talking once again about balanced forces. And what are the forces that are balanced in this case? The same two we've had the whole time. Our weight is not changing, but the tension must have decreased so that it's not more than the weight anymore. Now it's the same as the weight. And again, that doesn't mean the elevator stops moving, it just means it stops accelerating. So it went from being greater in the previous question to decreasing back to being equal. So Ft equals Fg. And again, we know they're balanced because there's no acceleration. And that means it is less than, or it's the same as it was in number 10 when it was just at rest. Balanced forces describe constant speeds or produce constant speeds, and they produce rest. Okay, let's move on to number 13. The elevator begins to slow as it reaches the proper floor. The tension now is less than 10, more than 10, more than it is in 10, the same as it is in 10, or less than it is in 10. Okay, so now the elevator is slowing down. Okay, if it's still moving upward, but if it's slowing down, that means the acceleration must be in the opposite direction. And one thing we know is that whatever direction your acceleration is in, that's the direction of the net force. So our net force is also downward. Well, what are the two actual forces acting here? Still have weight and still have tension. But the tension is now less than the weight. And we know that it's less than the weight because the force of gravity, the weight has to be winning. So it doesn't mean that it just immediately stops going up. It means that it is going to slow down. And we know that the tension is less than it was in 10. Again, the force of tension now is less than the force of gravity. All right, so then for number 14, the elevator now starts to descend at an increasing speed. The tension would be more than it is in 10, the same as it is in 10, or less than it is in 10. This is really the same situation that we just had in the previous question. The weight is not going to change. The acceleration is still down, but now the motion is down as well. This means if these two things are together, that means you're speeding up. All right, this means because the acceleration is down, that means our net force is down. All right, again, the tension is still here, and if the net force is down, that means gravity has to be the winner between these two, which means this has to be less than gravity, which means that it is less than it was in number 10, because in number 10, they were equal. So again, tension is less than gravity. All right, and finally we come to number 15. If the cable snapped and the elevator fell freely, the tension would be, well, you don't really have to do much for this one. Again, we still have gravity, but now it says it's falling freely. The cable snapped, the cable's up here, the cable is not pulling. There is no force from the cable, so there is no tension. Free fall means you only are under the influence of gravity. So this would be, again, less than it is in 10. In fact, it would be